Alright guys, you're going to be taking notes over chapter 4.1, so you're going to learn how to graph quadratic functions in standard form. I'll probably go kind of fast, so just pause the video whenever you need to, and you can always rewind if something did not make sense. Alright, so we're going to graph quadratic functions in standard form. We'll learn two other forms of quadratics later on this unit. We'll learn how to find minimum and maximums by hand and in the graphing calculator. And then this is what you were looking at in your investigation yesterday. How do you recognize different transformations that are occurring to the parent function? All right, so the parent function of a quadratic equation is either f of x equals x squared, or that's the same thing as y equals x squared. So either one, they mean the exact same thing. Remember, a parent function is just the most basic function in a family of functions. We've got lots of different characteristics of quadratic functions. You should have noticed from your investigation that they're shaped like a parabola. That's just that U-shaped graph, and it better be a smooth curve. So don't make it have any sharp corners, especially at the vertex. It should just be a smooth curve representing a parabola. Its domain, remember that's the x values that you input into the function, is all real numbers. You can put anything you want into the function x squared. There's no restrictions on that, so the domain's all real numbers. The range will change depending on what transformations occur, and I'll kind of talk about that as we graph more of these. But every single quadratic has a domain of all real numbers. And then the last thing you need to know is that each parabola either has a minimum or a maximum value. Minimum or maximum value. That's what we'll find by hand and in the graphing calculator. So what I want to do is graph the parent function y equals x squared. And you should have graphed this on your investigation as well. I'll just graph the points where x is -2 all the way to 2. And the way you can get those outputs is by plugging x into your function. So if I plug in -2, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. We can plot each one of those points. And if you connect them with a smooth curve, there is your parabola. Notice that it's symmetric. When I plugged in -2 and I plugged in 2, I got the exact same output, and same with -1 and 1. Just like with graphs of absolute value functions like we looked at earlier in the year, it's got an axis of symmetry. Your axis of symmetry will always be a vertical line, and notice it goes through the vertex, which is either your minimum or your maximum. So why don't you go ahead and label 0, 0 as your vertex. That's the turning point in your graph. So we go from decreasing, here's my vertex, to increasing. And if your parabola is facing up like this, that's your minimum value. That's the smallest your graph is ever going to get. So this is the most basic. As you saw in the investigation, this can get wider, it can get narrower, it can move up and down, and it can even flip over. Those are all the different transformations that can occur to a parent function. So the first form we're going to look at is standard form. That is y equals ax squared plus bx plus c. Again, that can be f of x equals, it just depends on how you're seeing it written. So if it's y or f of x, you do the exact same thing. When it's in standard form, These are some properties that we need to understand about what's going to happen to the graph based off of what your values for A, B, and C are. And those will just be numbers substituted into your equation. So if the coefficient is greater than 0, if it's positive, that means you're going to have a graph that faces up.
They used to be my coach. Yeah, when we were do math. Somehow can't use a calculator. It's just her. It's just the text.
Okay.
So, thanks.
Yeah. So if the graph faces up, it'll look like this. And if it faces up, then the vertex is just going to be a minimum value. If the coefficient is less than 0, then your graph is going to face down. So that would be a reflection over the x-axis, and then the vertex would be up top, and that would be your maximum. Now, if your coefficient, we have the absolute value bars here because we're ignoring the sign. If the coefficient is less than 0, or less than 1, well, we should say greater than 0. So if it's a fraction from 0 to 1, it's going to be wider than y equals x squared. And we talked about that with absolute value. That would be a compression. And then if it's greater than 1, like 2, 3, 4, so on, then it's going to be narrower than your parent function. And that would be a stretch. When we graph in standard form, we always need to figure out where the axis of symmetry is. And remember, that is the x value of the vertex. We have a formula that we use to find the axis of symmetry. It's x equals the opposite of b over 2 times a. I say the opposite of b because that's what that negative sign's meaning. If b is negative, make it positive. If b is positive, make it negative. And then you're dividing by 2a. And remember, a, b, and c are the coefficients in standard form. So that is your axis of symmetry. That's a vertical line through whatever number this happens to be, and that's also the x value of the vertex. So if I want to find the point for the vertex, that's the x value. So I'll write an ordered pair. Negative b over 2a, that's the x value, whatever number that is. And to find the y value, I'm going to take this number and substitute it into my function. So to represent that, I say f of the opposite of b over 2a. That just means we're taking this x value, substituting into the function, and getting the output. That'll be your y value. The y-intercept we also need to know when graphing, and it's just 0c. That's the constant from your standard form. So c is whatever that number is. Whatever that number is, that's where you're crossing the y-axis. All right, so let's try to graph one. So go ahead and make a coordinate plane in your notes, negative 10 to 10, and then this is the first one in standard form that we'll graph. I always want you to recognize at first what's the leading coefficient and what's the constant. That's going to tell you two big things about your graph. Since the number is 2, we know it's going to be a little bit narrower than the parent function. 2 is positive, so we know that it's going to face up. That means it's going to have a minimum value, because your parabola will look like this, and that's your minimum. 6 is c, that's your constant, so that's your y-intercept, 0, 6. So always kind of think about these things before you actually start to graph it. You should have a picture of what you think the graph will look like before you even start. I have some just tips or steps to follow off to the side. Always identify your coefficients. Do you know what a, b, and c are? So in this case, a is 2, the coefficient in front of x squared. B is negative 8, the coefficient in front of x. And C, we already said, was 6. That's the constant. We have to know the vertex if we're going to graph. Remember, the vertex is your minimum or your maximum, depending. In this case, I know it's the min. So to find the vertex, I first find the x value. X equals the opposite of b over 2 times a. The opposite of b is 8. It was a negative 8. Multiply that by a negative 1. It's positive 8. Over 2 times a is 2. So 8 divided by 4, your x value is 2. So I know I have an axis of symmetry at x equals 2. You don't always have to draw the axis of symmetry, but you can, when you're done, make sure that it's symmetric about that line. So that's the x value of my vertex. To find the y value, I substitute 2 in here. So I'm going to say f of 2. Everywhere I see an x, replace it with a 2. So 2 squared is 4 times 2 is 8. Negative 8 times 2 is negative 16. Plus 6 gives you negative 2. So your vertex is 2, negative 2. So I can plot that point. Notice the vertex is on the axis of symmetry. Now I need to identify my y-intercept. We already did that. That's 0, 6. So I can plot that point. And then use symmetry to find a third point and make a parabola. So my y-intercept is 2 units away from my axis of symmetry. So I'm going to go 2 units the other way, kind of reflect that point over. So notice they're symmetrical. And then just connect your 3 points with a smooth curve. And there's your parabola. So every time you will find the vertex, find the y-intercept, use symmetry to find a third point. The domain of this is all real numbers. The range, notice we've shifted down from the parent function. So your smallest value, your smallest y value is negative 2. So your range is y is greater than or equal to negative 2. All right, let's try another one. So think about what it's going to look like. It's got a negative coefficient. That means our graph is going to face down. It's going to look like this. This time it's going to have a maximum. Negative 8, that's your y-intercept. So we'll have a y-intercept of 0, negative 8. First thing we need to do is find the vertex. To find the vertex, you need to know the axis of symmetry, which is the same thing as the x value of the vertex. So x equals the opposite of b over 2 times a. B is 6, so the opposite of 6 is negative 6, over 2 times a is negative 1. So negative 6 divided by negative 2, the x value is 3. To find the y value of the vertex, substitute 3 back in. So I'm going to say f of 3, negative times 3 squared, plus 6 times 3 minus 8. 3 squared is 9, times negative 1 is negative 9, plus 18 minus 8. So the y value of my vertex is 1. So my point for my vertex is 3, 1. Remember, the axis of symmetry is x equals 3. That's the vertical line through x equals 3. So your vertex lies on your axis of symmetry. We also need to know the y-intercept if we're going to graph, and we said that was 0, negative 8. So go down negative 8, plot a point. That's 3 units away from the axis of symmetry, so I'm going to go 3 units the other way to make them symmetrical. and then just connect them with a smooth curve. Try to go through your point. And there's your parabola facing down with a maximum at your vertex of 3, 1. So always be thinking about your domain and range. Domain is always all real numbers. Your range, your y values are now less than 1. So y is less than or equal to 1. Notice that's the y value of the vertex. All right, this one's going to be a little bit different. Notice that it doesn't have a bx or a c. It's just ax squared. We do know that since it's got a negative coefficient in front, we know it's going to face down. And we know that's a maximum when it faces down. It doesn't have a c value. C is 0. So that means the y-intercept is 0. So let's still follow the same steps and find the vertex. To find the vertex, I have to find the axis of symmetry. X equals the opposite of b over 2 times a. There is no b value. So b is 0 divided by 2 times a is negative 2. 0 divided by anything is 0. So the axis of symmetry is x equals 0. To find the y value of the vertex, plug 0 back in. Negative 2 times 0 squared, that's just 0. So my vertex is at 0, 0, which makes sense because the y-intercept's 0. But now I only have 1 point, and I've done the vertex and the y-intercept. So I can't even use symmetry yet because I only have 1 point. So when this happens, you need to go ahead and make a t-chart, and you need to find 2 more points. I usually just do the points to the right and to the left of the vertex, so maybe negative 1 and 1. You know that those are symmetric, so if you plug in negative 1, negative 1 squared is 1 times negative 2 is negative 2. That has to be the same output because it's symmetric. So negative 1, negative 2, 1, negative 2. So if you find the vertex and the y-intercept and they happen to be the same thing and you don't have any more points, just pick some x values to plug in and get y values out. It does not matter what x values you pick. You can even just do 1 and then use symmetry to find the third. Here, domain is all real numbers. Range, all your y values are less than 0. So y is less than or equal to 0. Okay, I want you to try this one on your own. So if you just want to pause the video, see if you can graph this one, and then when you're done, play and see if you got it right. So think about the characteristics. It's a negative in front. You know it's going to face down, so it's going to have a maximum. The y-intercept is 2. So if we're going to go ahead and find the vertex, we need the x value of the vertex, opposite of b over 2 times a. B is negative 5. The opposite of that is 5 over 2 times negative 1/3. That's the same thing as 5 over negative 2/3. 2 times negative 1 is negative 2. You can multiply by the reciprocal. So that's negative 15 halves, which for graphing purposes, a decimal is probably most helpful, negative 7.5. And you can just plug this into your calculator if you want to, as long as you put negative 2/3 in parentheses. So to get the y value, plug in negative 7.5 for all of your x's. So f of negative 7.5, negative 1/3 times negative 7.5 squared minus 5 times negative 7.5 plus 2. So I would probably in my calculator just do negative 7.5 squared times negative 1/3, negative 18.75. Negative 5 times negative 7.5 plus 37.5 plus 2. That gives you 20.75. So your vertex is negative 7.5, 20.75. And we know the y-intercept is 0, 2, because 2 is the constant. So I'm going to go ahead and just count by 2's. I'll go off a little bit to give me 22. You can do that on all sides. So go over about negative 7.5, so 2, 4, 6, 7, up 20.75. You're going to have a y-intercept at 0, 2. So go 7.5 the other direction. About right there. And connect them to make a smooth curve. Here the domain is all real numbers, and the range y is less than or equal to 20.75. Y value of your vertex. Okay. You have found the minimum or the maximum by looking at the vertex. When we talk about the minimum or the maximum value, that is the y-coordinate of the vertex. Only the y-coordinate. So the minimum isn't the vertex, it's the y value of the vertex, and same with the maximum. So if we want to find that by hand, all we have to do is act like we're finding the vertex. So we find the x value of the vertex, substitute it back in to find the y, and that's your min or your max. So use the same formula, x equals the opposite of b over 2 times a. B is 16, so the opposite is negative 16 over 2 times 4. That just reduces to negative 2. That's not my min or my max. I need the y, so plug negative 2 in here and here. So I can just do f of negative 2, 4 times negative 2 squared, plus 16 times negative 2 minus 3 gives you negative 19. That is your minimum. I know it's my minimum because 4 is positive, so this parabola would face up, which means it has a minimum. So negative 19 is the minimum value. Now, on your homework, you'll be asked to do this in your graphing calculator. So here's your steps if you want to copy those down really quick. And then I'll show you how to find the minimum. We'll just do this same example in the graphing calculator. So you need to go to your y equals and substitute in whatever function we're doing. And I'm just going to do the same one as above. So 4x squared plus 16x minus 3. Step 2 says to graph, but you may need to change the window. So I'll show you what that means. I already changed the window. So yours will look like this. Zoom 6 to get this one. Notice you can't see the minimum. So that means I need to change my window so that I see more negative y values. So click window. I need to change my y minimum. So maybe I change it to negative 15 and graph it. I still can't see it. So go back to your window and make it a little bit bigger. Maybe I'll do negative 25. Graph it. Now you can see it, but you want the calculator to tell you what that value is. So step 3, calculate the max or the min. To get to calculate, you have to do second trace. So second trace. I'm finding the minimum because the parabola is facing up. So scroll down to 3 and press enter. And it's going to ask you a bunch of questions. So left bound, move your cursor to the left of wherever you think the minimum is. So maybe right about there. Press enter. Notice an arrow pops up. And it says right bound. So move your cursor to the right of wherever you think that is and press enter. You don't want to guess, so press enter again. And it tells you your vertex is -2, -19. -19, the y value is your minimum, which is what we got when we did it by hand. So you'll be asked to do it both ways. By hand, you have to find the vertex, and it's the y value, and then that's how you do it in your calculator. Okay, the last thing I want to look at is a few word problems. We'll do a lot of word problems this unit. A lot of them, like I talked about at the beginning, will be based off of like bridges. We'll be finding the height or the minimum, or we'll talk about like the height of throwing a ball. We'll see a lot of problems like that. So this problem says that each cable joining the 2 towers on the Golden Gate Bridge can be modeled by this function, where x and y are measured in feet. What is the height above the road of a cable at its lowest point? So I want to find the minimum, in other words. You don't have to graph it, but we do know that the parabola would face up because 1/9,000 is positive. So it would have a minimum. So really all we have to do is find the vertex. So I have to find the x value first. X equals the opposite of b over 2a. B is -17/15. So the opposite is 7/15. Over 2 times a is 1/9,000. If we're doing this by hand, that's 7/15 over 2/9,000. Dividing by fractions is the same thing as multiplying by the reciprocal. So 7/15 times 9,000 over 2 gets you 63,000 over 30, which turns out to just be 2,100. That's not what I want. I need to plug 2,100 into the function. So f of 2,100, 1/9,000 times 2,100 squared minus 7/15 times 2,100 plus 500. So I would do this part, simplify it down, you get 490. Make sure you know how to do that in your calculator. 7/15 times 2,100, I get minus 980 plus 500. Ends up just being 10. So what that tells me is that the lowest point of the cable above the road is 10 feet. So we could say the lowest point is 10 feet above the ground. So what we're talking about is the cables on the bridge. So if you have the cable, this distance at its lowest point would be 10 feet. Here's your parabola that the cable makes. Okay, here's a similar one where you're given a function that models the jump of a kangaroo. What is the kangaroo's maximum height? You're asked to find the maximum. You know this would have a max because that's negative, so your parabola would be facing this way. If you think about a kangaroo, it would start here and jump up and come back down. So that would be the shape of it. We're trying to find the maximum height. So pause it and try to find that, and then you can replay it to check your answer. So you need to find the vertex. X equals the opposite of b over 2 times a. B is 0.84, so negative 0.84 over 2 times a is negative 0.03. That reduces to 14. Plug 14 back in. F of 14 is 6. So that means that 6 feet is the maximum height of a kangaroo. Should I say a kangaroo's jump? All right, so here's your assignment. Make sure on 34 through 38 even, you're using your calculator to find the max and the min. On all of these, you're graphing, please use graph paper and make sure you put a scale on your graph. And you will turn this in next block day.